All right, today we're going behind the lens. We're going to talk about the tiny, powerful electronic eye at the heart of every single camera. The piece of tech that truly makes all our pictures possible. Let's get right into it. So let me ask you a question. What's the most important part of your camera? I mean, really, what's the most critical piece? I bet for most of you, the first thing that comes to mind is that big, beautiful piece of glass right on the front. The lens, right? And you'd be close, but not quite right. See, the thing is, while the lens is absolutely crucial for focusing the light, it doesn't actually see a thing. Nope. The real magic, the part that's really doing the work of capturing the world, that's something else entirely. It's this, the image sensor. This little chip right here, this is the digital version of film. It's basically the retina of your camera. It's the surface where light gets transformed into the digital ones and zeros that become your photos and videos. This thing right here is without a doubt the real hero of digital photography. Okay, so how on earth does this tiny chip pull off such a huge job? I mean, how does it take light, actual photons flying through the air, and turn them into a file on your phone? Let's really get into how your camera actually sees the world. When you boil it all down, the idea is actually pretty simple. An image sensor is just an electronic device that records an image, and it does that by measuring light. That's it. The brighter the light that hits any given spot, the stronger the signal it creates. The real question is, how does it do that millions of times for every single picture, all in perfect sync? Well, it's kind of like a three-step dance. So first up, light comes through the lens and hits the sensor's surface, which is covered in millions and millions of tiny pixels. Then, for step two, each one of those pixels basically acts like a tiny solar panel. It takes the light it gets and converts it into a small electrical charge, just a little collection of electrons. And finally, the camera's brain measures the charge from every single pixel, turns that into a digital number, and then stitches all those millions of numbers together to create your photo. A really great way to picture this is to think of the sensor as a giant grid made up of millions of tiny little buckets. Okay, so when you hit the shutter button, you're letting the rain, which in this case is light, fall into all those buckets. Naturally, some buckets are going to get a lot of rain, some will get just a little. And the sensor's whole job is to just measure exactly how full each and every bucket is. That's how it rebuilds the scene. Okay, but here's where it gets really clever. The sensor itself, it's completely colorblind. Each one of those little buckets we just talked about can only measure brightness, black and white. So how does it see in color? Well, engineers came up with this brilliant solution. They put a microscopic filter over the pixels, usually in a pattern called a Bayer array. It filters for red, green, and blue light. Then the camera's processor combines all that data to figure out the true color. And get this, did you notice there are twice as many green filters as red or blue? That's totally on purpose. It's designed to mimic how our own eyes are more sensitive to green light. So cool. Now, for a long, long time, there were basically two dominant technologies out there, and they were fighting it out for the soul of the digital camera. This was the great sensor showdown, CCD versus CMOS. At first glance, the difference might look kind of subtle, but trust me, it's huge. Over on the left, you've got a CCD sensor. It's the main attraction, sure, but it needs a whole team of supporting actors, all those other chips on the board, just to process its signal. But on the right, you've got the CMOS sensor. It's a whole system on a single chip. All that extra stuff, the amplifiers, the converters, it's all built right into the sensor itself. And that one thing, that integration, is the key difference. And that one difference in integration leads to some massive gaps in performance. See, CCDs read their data like a bucket brigade at a fire, passing the charge from one pixel to the next, all the way to a single output. The quality was great, but man, was it slow and power-hungry. CMOS, on the other hand, reads every pixel on its own. This makes it way, way faster, much more power efficient, and a whole lot cheaper to make. And those differences, well, they were going to decide the whole war. And you better believe it, there was a clear winner in this fight. So what was the final knockout punch that gave CMOS total and complete dominance? It all came down to image quality when things got tough. CCD sensors had two, they were fatal flaws. First, blooming. That's when a really bright spot in your picture totally overwhelms a pixel and its charge just spills over into its neighbors, creating this ugly blob effect. Then there's smearing. That's the vertical streak you see from bright lights, like headlights, at night. That happens because charge can leak while it's being passed down that slow bucket brigade line. And the CMOS sensor, because it reads every pixel directly and super fast, it just doesn't have these problems at all. And I mean, look at this chart. It tells the whole story, doesn't it? The battle, it wasn't even close. Today, CMOS technology doesn't just dominate the market, it is the market. We're talking a mind-blowing 98.4% share. CCDs are basically gone, just hanging on in a few very specific niche jobs. It was a complete and total takeover. The final nail in the coffin really came back in 2015. Sony, one of the biggest sensor makers on the planet, announced they were stopping all of their CCD development. That was it. That was the official end of an era. The tech battle was over. CMOS had won, period.
Okay, so now we know what's inside pretty much every camera out there today. So let's talk about those specs you always see advertised, right? What do all those numbers, megapixels, f-stops, what do they actually mean for the photos you take?
All right, first up, the big one everyone talks about, resolution, measured in megapixels or MP. It's really simple. This is just the total number of those light-collecting buckets on the sensor. So a 12-megapixel camera, that's 12 million pixels. More pixels generally means you can capture more detail, and you can print your photos out much bigger.
But, and this is a huge but, there's a critical trade-off. Think about it. If you keep cramming more and more pixels onto the same size sensor, each individual pixel has to get smaller. And smaller pixels, they're just smaller light buckets. They're not as good at collecting light, and that means your pictures are going to suffer when it gets dark. This is the big balancing act that all camera designers have to deal with. So you might be wondering, how do modern phones with these insane 108 or even 200 megapixel sensors get around this? Well, they kind of cheat. They use this brilliant software trick called pixel binning. When the lights are low, the phone's software digitally combines a group of pixels, say 4 or 9 of them, into one giant superpixel. Sure, you lose a little bit of that crazy resolution, but what you gain is a massive boost in light sensitivity. It's a clever way to get the best of both worlds.
Last but not least, let's talk about aperture. This is the opening in the lens that controls how much light actually gets to the sensor. Now, this is the part that always confuses people because it's a fraction. So a smaller f number, like f1.8, actually means a larger opening than, say, f2.8, and a larger opening lets in more light. That is absolutely key for getting those bright, clean photos, especially when you're shooting at night. But here's the thing. This technology has grown way beyond just our phones and fancy cameras. In this last part, we're going to see how these little electronic eyes are quietly powering a revolution that's happening all around us, every single day. The scale of this thing it's almost hard to wrap your head around. The market for just these tiny little chips is projected to be worth almost $50 billion by 2030. That's not just big, that means this tech is becoming a fundamental building block of our modern world.
And why does this matter to you? Because these sensors are now absolutely everywhere. They're the eyes for self-driving cars, they're what powers the medical scanners that literally save lives, they guide robots on factory floors, they're the backbone of pretty much every modern security system. From the tablet in your hand to the Hubble Space Telescope, it's the same core technology doing the work. So let's end with this thought. This technology, which really just started as a way to take a family photo without using film, is now what allows machines to see, to understand, and to navigate our world. The evolution of the image sensor is one of the most important, but also one of the most unsung tech stories of the last 30 years. And as these electronic eyes get smaller, faster, and a whole lot smarter, you just gotta wonder, what are they gonna show us next?